First of all, this is a tunnel, and it was bored out by a subway tunneling machine, which literally was rented from a company in New York City. Came up and just went underneath the field. We're about 50 feet underground right here. So if you travel up in the K-lot, as I think it used to be known, there's a soccer field up on top of this. When we go back up, if you notice on that poster, the circle is underneath the athletic fields. First of all, you'll notice, just like in kindergarten, if you color code things, it really helps, right? So we've got, you're looking at magnets, a lot of electromagnets. You're looking at orange ones and yellow ones and blue ones, and they all do different things. On the inside of the ring, so behind me, actually behind most of you, that's the first accelerator that was built. So this stainless steel can, what is it? Well, it's a vacuum chamber. We suck out as much air as possible. And then you put the electrons in, and they get going faster and faster. If there was air in there, they'd crash into the air, and they'd scatter and slow down, and they'd never get going fast. So you have to have vacuum. So we do a lot of work on vacuum, trying to get rid of all the air. And then what we have in here also are magnets that are just like the ones outside. But let me turn your attention now to the outside of the ring. So this is a large vacuum vessel as well. So this aluminum chamber here, this is just a big pipe. You'll notice it's about this big in size, about 4 or 5 inches. It's hollow, and it goes all the way around. And then there are all these pumps here that actually just constantly suck the air out, because air leaks in very slowly, even through the metal, sucks the air out. And then there's a lot of water cooling. You see the blue hoses are cold, and the yellow are hot. And what are they doing? They're taking heat away from these electromagnets. An electromagnet, you run electricity through a coil, and it makes a magnetic field. And the magnetic field is which steers the electrons around. Now the electrons are moving in free space. So you can't, if they're in a wire, what do you call that? That's electricity. So electrons in a wire are electricity. Electrons in a battery are giving you power to run your cameras. Okay, that's electricity. But in this machine, the electrons are in free space. They're traveling in nowhere, in nothing. So the only way to make them curve and go around a circle is to produce a magnetic field. And so these orange magnets, these produce a magnetic field. You put electricity in the coils, and they produce a magnetic field. And when particles travel, you'll learn this when you study physics, when particles travel through a magnetic field, if the magnetic field is up and the particle's traveling that way, you use your right hand, and your finger says there's a force in. So if I'm an electron traveling that way, I would feel a force in. And if you look, the orange magnet, you see it curving that way to make particles go around in a circle. That's how we make particles go around in a circle, when you can't hold on to them or put them in a wire. So there's no wire. Now, I have you thinking about one electron, but actually it's more like Carl Sagan would say there are billions and billions of electrons, and they're in a cloud. And electrons, you'll also learn this in physics, or in electricity and magnetism, or electricity for engineers. When you have particles that have the same charge, they hate each other and they repel. And so the particles in this cloud, they grow. They just want to get away from each other. That's why if I had hair, I could do that static electricity thing, right? My hair would stand on end because the electrons want to get away from each other. So in this machine, we've got a cloud of electrons in this pipe, and it's coming along, and the cloud is growing. So how do you get it to go small again? If it goes too big, it'll hit the walls and be. So the way you get it to go small is you use a lens to focus. Now I can't use a lens like my glasses, because if the electrons hit it, they'll scatter. So we use a magnetic lens. So these blue magnets have 4 poles. You see north, south, north, south. It's called a quadrupole, 4. And the yellow ones have 6 poles, north, south, north, south, north, south. These are called sextipoles. Sex for 6, sextipoles, okay? And so when you have a 4 quadrupole and a sextupole magnet, it creates a lens-like field. So the cloud of electrons that's growing starts to shrink. And then it grows again, and you see there's another yellow-blue pair down there that shrinks it again.